So my name is Bilal, and today we'll be solving additional mathematics session October November year 2023, paper 2, variant 2022. So now moving on. Before moving on, I would like to say that please do like, share, and subscribe our channel. So we'll be starting with question 1, A part, which states a straight line passes through the points this. Find the point of intersection P of this line with this line. So first of all, we need to calculate the equation of the line. So that would look like, let's just calculate the gradient first. So this would be y2 minus y1, this y2, this is y1, 29 minus 23 over negative 8, negative 4. This would give us our final answer as 6 over negative 12. So this would be negative 1 over 2. Let's just write our whole equation. This would look like y minus y1 m x minus x1. An equation of line can be written like this as well. So this would be y minus 23. We are using 4 and 23 coordinates. So the and our gradient is negative 1 over 2 x negative 4. This would look like this. Now we need a point of intersection, right? So for point of intersection, this means to calculate the point of intersection, this means we need to solve the equation simultaneously. So substituting y is equals to 2x plus 5, which was given in the question, this in equation 1. Let's call it an equation 1. So this would look like 2x plus 5 negative 23, and this 2 would be multiplied over there. So this would be 2, and this would be negative x, negative 1 into x, negative 1 into 4 would be plus 4. So this would finally look like 2x minus 18 multiplied by 2. This would be minus x minus 4. So this would be 4x negative 36 plus x negative 4 equals to 0. So this would finally look like 5x equals to 40, x equals to 40 over 5. That would be x equals to 8. And then we'll substitute x equals to 8 in this equation finally, and that would be y is equals to 2 multiplied by 8 plus 5. So this would be 2 into 8 is 16, 16 plus 5 is 21. So we'll have our final coordinates as x comma y equal to 8 comma 21. Now moving on to part B, find the distance of P from the origin. It's a simple question. 8 comma 21 are given, and distance between this is to be calculated. So we'll simply be using 8 whole squared and then 21 whole squared. Sorry. So this would look like root 505, or we can write this as 22.5 approximately. Now moving on, we have our question 2, where it is written that find the non-zero value where k should not be equals to 0, for which the line y is equals to minus 2x minus 6k is a tangent to the curve y is equals to this. So first of all, we need to equate those equations. So we will be substituting equation 1, substituting equation 1 into in equation 2. Let's call this equation 1 and let's call this equation 2. So this would look like negative 2x, negative 6k, negative 1, x squared plus 2kx. We'll bring all the things on one side. So this would look like x squared plus 2kx plus 2kx plus 2x plus 6k plus 1 equals to 0. So let's just take x as common over here. So this would be 2k plus 2 and then 6k plus 1. We have our a as 1, we have our b as 2k plus 2, we have our c as 6k plus 1. So when it is a tangent, when there is a tangent, our discriminant is 0. What do we mean by discriminant? Discriminant is basically b squared minus 4ac equals to 0. So our b is 2k plus 2 whole squared, negative 4. Our a is 1, our c is 6k plus 1. We'll solve this equation. We'll get our answer as 4k squared plus 8k plus 4 negative 24k. Sorry. And then negative 4 equals to 0. Positive 4 and negative 4 would be cancelled out. We'll be left with 4k square. Negative 16k equals to 0. 4 would be divided by the whole equation. We'll be left with k squared minus 4k equals to 0. Taking k as common, this would be k minus 4. We'll not be using k as 0 because the question stated that it needs non-zero values of k. So moving on, we have our question 3 where we are not allowed to use the calculator. A cylinder has base radius this, a volume, and volume as this. Find the exact value of its height, giving your answer in the simplest form. So volume of cylinder can be written as pi r square h. Our volume is given as pi 16 plus 9 root 3 is equals to pi, our r is 2 plus root 3 whole squared h. Pi and pi would be cancelled out and our h would look like 16 plus 9 root 3 over 2 plus root 3 whole squared. So what we can do is just expand this first, and this would look like 16 plus 9 root 3 would be as it is, and then below it would be 4 plus 4 root 3 plus 3 equals to h, and then finally it would look like 16 plus 9 root 3 over 7 plus 4 root 3. We'll be multiplying by the conjugate to get a proper number in the denominator and not a rational number in the denominator. So this would be finally written as 7 into 16 would be 112, and then 7 into 9 would be 63 root 3, then negative 4 into 16 would be 64 root 3, and then negative 4 into negative 4 into 9 would be 36 multiplied by 3 would be negative 108, and then we can use a minus b, a plus b, which is equals to a squared minus b squared formula over here. So this would look like 49, 7 squared minus 4 squared is 16 multiplied by 3 is 48. So finally our answer would look like 112 minus 108 is 4, and then 63 minus 64 is negative root 3, and denominator will have 1, so we don't have to write. So this is our final answer. Moving on, we have our question 2 where it says just solve the following equation, this. So let's see how this equation solves. This would be e powered 2x plus 2, and at the bottom or the denominator this would look like, since this is a square root, it can be written as e powered x upon 2. So this would be e powered x upon 2 equals to 10. Let's simplify this a little bit and bring this power upwards. So this would look like e powered 2x plus 2 negative x over 12 equals to 10. So this will finally look like e powered 3 over 2x plus 2 equals to 10. Then we can apply ln on both sides. Applying ln on both sides. So this would be ln e power 3 over 2x equals to ln 10 plus 2. Sorry, I forgot plus 2. Ln e is 1, so this would come over here, and our final answer would look like 3 over 2x plus 2 on our left hand side, and this would be finally written as ln 10 minus 2 multiplied by 2 over 3 equals to x. Or you can write this answer This would be accepted, and you can write the our final answer as x equals to 0.2017. This can be our final answer as well. Now moving on to part B, which is written as 2 log 9y minus log 9 4y minus 9 equals to 1 over 2. Let's just solve this first. So this would look like log, by using the power law, this power would come over here. This would be log 9y square, and then this would be minus log 9 4y minus 9 equals to 1 over 2. Let's just use the law quotient law of logs. So this would be log 9 y squared over 4y minus 9 equals to 1 over 2. Now let's remember that if we want to go from log to exponential form, we use the base, use this as power. This is 1 over 2, sorry, my mistake. Use this as power and equate it to this part. So this would be y squared 4y minus 9. 9 powered 1 over 2 is simply 3. And this would be multiplied by 4y minus 9 equals to y square. We can solve this and bring this whole thing over here. So this would be y squared minus 12y plus 27 equals to 0. So this would look like y squared minus 3y minus 9y plus 27 equals to 0. Taking y as common, this would be y into y minus 3, 9 minus 9. And then this would be y minus 3 equals to 0. We have our y as 3 and y as 9. We can plug in both y values and check that whether they are valid or not. And when we check y equals to 3, it is valid. When we check y equals to 9, it is also valid. So both are valid. You can simply do this in mind. 3 squared is 9, and then 4 into 3 is 12. 12 minus 9 is positive. So this would be all right. And then plugging in 9, so this would be y squared would be 81, and then 4 into 9 is 36. 36 minus 9 would give us positive answer. So it is a right part. Now moving on to question 5, where it states find the equation of the normal to the curve y is equals to this at the point this. We are given with both the points. Since we need to calculate the equation of the normal, we need to calculate the dy by dx, which will give us the tangent's gradient. So this would be 3x squared negative 14x, I guess, plus 12. So our what can I say, our dy by dx would look like this. Let's substitute x equals to 1 over here. So this would be 3 negative 14 plus 12. So this would be 1. Gradient of tangent is this. Gradient of normal can be written as negative 1 over 1. So this can be simply written as negative 1. So this would be y minus 1. We'll be using this, and the previous equation, that was y minus y1 m x minus x1. This would be y minus 1 negative 1 x minus 1. So this would be y equal to negative x positive 1 and then positive 1. So this would be plus 2. So our final equation would look like this. Now moving on to part B, where it states find the x coordinate of the 2 points where the normal cuts the curve again, giving your answer in the form x equals to a plus minus root b, where a and b are the integers. So when the question asks for cuts the curve again, which this means we need to solve the two equations simultaneously. Our curves equation was something like this. This would be x cubed minus 7x squared plus 12x minus 5, and our equation of normal was negative x plus 2. We can substitute this over here. So this would be negative x plus 2 x cubed minus 7x squared plus 12x minus 5. So this would be x cubed minus 7x squared plus 13x minus 7. Now here we need to do some trial and error to calculate the first root. Our first root would look like x equals to 1. If we plug in x equals to 1, what we get is So we get a 0, which means x minus 1 is a factor. We need to calculate the other two factors. What will our other two factors would look like? So let's just perform a long division. So this would be x minus 1, x cubed minus 7x squared plus 13x, and then minus 7. Sorry. So this would be multiplied by x squared, and this would look like x cubed negative x squared. This would be multiplied by negative, so this would be positive, and this would look like negative 6x squared. And then this positive 13x would come down, and then we can multiply it by negative 6x to cancel this. So this would be negative 6x squared and positive 6x. So we're multiplying it by negative, and this would cancel out. This would be negative, and we'll get our answer as 7x minus 7. And we can then just simply take plus 7 over here, and then this would be simply cancelled out to give our remainder as 0. So we have our other two roots as x squared minus 6x plus 7 equals to 0. Now here a is equals to 1, b is equals to negative 6, and c is equals to 7. We can apply the quadratic formula, which is x equals to minus b plus minus b squared minus 4ac equals to over 2a. So this would be 6 plus minus 36 minus 4 into 1 into 7 over 2 into 1 is 2. So this would be 6 plus minus 2 root 2 over 2, and this we take 2 as common in the denominator, so this would be cancelled out, and we will have our answer as 3 plus minus root 2. So this is our final answer. We can write a as 3 and b as 2. Now find the exact value of this. We need to calculate the final value of this. Let's just expand this and then divide it by x. So this would look like x squared plus 4x plus 4 over x dot dx. Let's just break this down. This would be this, and this would be this, and then this would be this. So this would be x plus 4 plus 4 over x dot dx. Now we can take a simple integration. So this would be x squared over 2, power increased, and then power would be going into the denominator, then plus 4x, then plus 4 ln x. Since it is 1 over x multiplied by 4, this would be ln x. Now we need to apply the limits that are 3 and 2. Applying 3 as the limit, you will get it as 9 over 2 plus 12 plus 4 ln 3. When we apply the lower limit, so this would be 2 plus 8 plus 4 ln 2, and here we'll be getting 4.5, and then this 12, this would be 16.5, and then this would be ln 3 powered 4. This would be 2 plus 8 would be 10, negative 10, then negative ln 2 powered 4. So this would be 6.5, 16.5 minus 10.5, and ln negatives are ln 3 power 4 over 2 powered 4. Let's just take whole powered as 4. So this would be 6.5 plus ln 3 over 2 powered 4, and finally we can write this as 4 ln 3 over 2 by using the power law. So this would be our final answer. Now moving on, this is question 7, where a particle is traveling in a straight line. Its displacement s meters from the origin at time t seconds is given by this equation, that is 1.5 e power 2t plus 2 e power minus 2t minus t. Now first part states find expression for the velocity v meters per second and acceleration a meters per second of the particle. So for velocity, we need to differentiate our distance formula. So this would be looking like this e power 2t would be 2 would be multiplied by 1.5. We will be getting 3 e power 2t This minus 2 would be multiplied by 2, so we'll be getting minus 4 e power 2t. E powered anything would remain same as it is, e powered minus 2t, and then minus t will have our differentiation as negative 1. So this would be our velocity. To calculate acceleration, we have to derivate velocity. We'll be derivating this function. So this 2 would be multiplied, we'll be getting it as 6e power 2t plus minus 2 would be multiplied by minus 4, so this would be 8, and e powered minus 2t, and this negative 1 would be 0, so this is our final answer. Now moving on to part B, which is find the time t seconds when the particle is at rest, which means v equals to 0. Now let's just simply equate e is equals to 0 in our this equation. So this would look like 3e power 2t negative 4e power negative 2t negative 1 equals to 0. Let's just simplify this a little bit. This would be negative 4 e power 2t negative 1. This is similar to something. Let's just substitute e power 2t as our x. So this would be 3x negative 4 over x negative 1 equals to 0. Multiplying whole equation by x. So this would be 3x squared minus x minus 4. So we'll be solving this and be getting it as 3x squared plus 3x minus 4x minus 4 equals to 0. 3x x plus 1 negative 4 x plus 1 equals to 0. We have our x equals to negative 1 and x equals to 4 over 3. We can't use x equals to negative 1 because we have to apply ln on both sides. So we'll be rejecting it here. Rejected. So we'll be using this equation only. So e powered 2t is equals to 4 over 3. Taking ln on both sides, this would be ln e powered 2t. Power would be coming over here. This would be ln 4 over 3. And then this would look like 2t is equals to ln 4 over 3. And then this 2 would be divided. So we'll get our final answer as ln 4 over 3 upon 2 as our t. Now we need to calculate the acceleration at time t seconds. Acceleration is required. Let's just move a little bit back. So this was our acceleration. Let's just write it below. So this was 6e powered 2t plus 8e power minus 2t. Let's just substitute t over here. So this would be 6e power 2 ln 4 over 3 over 2 plus 8 negative 2. This would be ln 4 over 3 over 2. So this would be cancelled out, and we'll have our negative power over here, and then this would look like this 2 and 2 would be cancelled out. 6. This would be e to the power ln is something, whatever is written in the brackets comes out. This would be 6 multiplied by 4 over 3, and then since this power is over here, so this would be 3 over 4, and this comes out, so this would be plus 8 into 3 upon 4. This and this would be cancelled out. This and this would be cancelled out. We'll get our answer as 8 plus 6, that is equals to 14. Now moving on to question 8, where a curve has equation this y is equals to x plus x sine 2x. We need to find dy by dx. We'll be using the product law over here, which means when two functions are multiplied, that is u and v, we get an answer as v u dash plus u v dash. So this would, we have our u as x and we have our v as sine 2x. So we'll write our answer as sine 2x into 1 plus 2x cos 2x. Since this is sine 2x and x differentiation is 1, and we have x as it is, and sine 2x differentiation is simply cos 2x, and then this 2 is multiplied over here. So this would be finally looking like this. Now in part B, find the equation of the tangent to the curve at x equals to pi by 4. Since we need the equation, we need to have y, our y. Let's just sort out our y. What will be our y? So our equation was y is equals to x sine 2x. Let's just plug in pi x equals to pi by 4. This would be pi by 4 sine 2 pi by 4. This would be cancelled out, and we'll get our y as simply pi by 4. We have our y as pi by 4. Now we need to calculate the equation of the tangent to the curve at this point. For tangent, we need to have our dy by dx or gradient. We have our dy by dx here, so we will simply be using this sine 2x plus 2x cos 2x. Substituting x equals to pi by 4 over here, so we'll get our final answer as sine 2 pi by 4 is simply 1, and plus 2 pi by 4 cos 2 pi by 4, and cos 90 is simply 0. So we'll get our final answer as 1. We have our m, we have our x, and we have our x, and we have our y. We can just simply put it in the equation. Y is equals to mx plus c. This would be pi by 4 1 plus c. This would be cancelled out. Our c would be 0. So our equation would be y equals to x simply. Alright. Now moving on to part C, which is use your answer to part A to find the exact value of this. Now to know what was written in part A, let's just move back. So this was our part A. We can write our part A as, when we calculated the differentiation of x sine 2x, we got our answer as sine 2x plus 2x cos 2x. Now we need the integration of this only. We need to move this over there. So this would be d dx x sine 2x negative sine 2x equals to 2x cos 2x. Integrating both sides, we'll have our final answer as, this would be cancelled out and this would be integrated simply. Just integrated. So this would be x sine 2x, and this sine 2x would be integrated to positive cos 2x over 2. Sine integrates to cos, positive negative cos, and then this 2 goes into the denominator. So we'll have our final answer looking something like this. We'll be applying the final limits. We are given with the limits as pi by 6 and 0. Pi by 6 and 0. We are applying the limits. So this would be pi by 6 sine 2 multiplied by pi by 6. This would be pi by 3 simply, plus 1 over 2 cos 2 pi by 6. So this would be pi by 3. So this is our upper limit. Our lower limit would be, this becomes 0, and cos 0 is simply 1. So this would be 1 over 2. Now we can write our final answer as sine pi by 6 multiplied by sine pi by 3. Sine pi by 3 simply gives us our answer as root 3 over 2 plus 1 over 2. Cos pi by 3 is 1 over 2, and we have to subtract 1 over 2 from here. This would be root 3 pi over 12 plus 1 over 4 negative 1 over 2, and then we'll have our final answer as root 3 pi over 12 negative 1 over 4. So this is our final answer. Now moving on to question 9, which states an arithmetic progression has 12 terms. The sum of the first 3 terms is negative 36, and the sum of the last 3 terms is this. Find the first 3 terms and the common difference. We need to find the first term and the common difference over here. So let's just make some equations. Sum of first 3 terms is equals to negative 36, and our equation would look like 3 upon 2, 2 into a plus n minus 1 is 3 minus 1 would be 2, and then d. So we take 2 as common and cancel it out. So this would look like 3a plus 3d equals to negative 36. Let's just simplify it a little bit and divide the whole equation by 3. So we'll get our answer as a plus d equals to negative 12. So this is our first equation. To calculate our second equation, we have to use the last three terms. What will be our last three terms? T10, T11 and T12. Our T10 would be a, since the equation of the nth term is a plus n minus 1 d, where n is the term, which what is the term. So a plus 10 minus 1 is 9d, a plus 11 minus 1 is 10d, and this is a plus 11d finally. So we add them all and equate it to 72, which was given in the question. So we get our final answer as a plus 30d equals to 72. This is our second equation. Let's just subtract this equation. Let's just subtract this equation from this equation. So this would look like negative a, negative d, and positive 12. So this would be cancelled out, and this would be simply written as I guess I made a mistake over here. So if we add them all, this would be 3a plus 30d equals to 72. Sorry, I made a mistake. We'll be dividing whole equation by 3. So we'll be getting our answer as a plus 10d equals to 24. This is our second equation. Now we need to subtract equation 1 from equation 2. So this would be a plus 10d minus a plus d equal to 72. Did I make some mistake again? Something. Sorry, this is not 72, this is 24. 24 plus 12. This would be 36 over here. And this a and this I would be cancelled out. This would be 9d, and our d would look like 36 over 9, that is 4. Now moving on to calculate a, we can substitute in any equation. We can use this equation, or we can use this equation as well. We will be using this equation. So this would be a plus 4 equals to negative 12, and our a would look like negative 16. So this is our final answer. Now coming on to part B, the first three terms of a geometric progression are 1, 1.2 and 1.44. Find the smallest possible value of n such that the sum of the first n terms is greater than 500. Sum of n terms is greater than 500. So let's just calculate the ratio. That would be 1.2 over 1, simply 1.2, and sum of n terms is given as a r power n. If we have our r as greater than 1, so this would be r, we'll be using this formula, r power n minus 1 and r minus 1. So we have our a as 1, we have our r as 1.2 powered n, and this would be 1, and this 1.2 negative 1 is 0.2, and we have our answer as 500. Since this has to be greater than 0, we'll be using this sign. This would be multiplied over there, so we'll be getting it as 100 plus 1. This 1 would be going over there. We'll have our answer as this. We can use log on both sides. This would be log 1.2 base 1.2 and 1.2 powered n log 1.2 and then 101. So we'll get our answer as n greater than log 1.2101 would be 25.31. So n should be greater than 25.31, and 25.31 is not integer, so this would be n is equals to 26 as our smallest n's value. Now moving on to our last question, I guess, that is question 10. By writing cot x and tan x in terms of cos x and sin x, show that sin x over this is equals to sin x over 1 minus cot x plus cos x over 1 minus tan x equals to this. So this would be sin x 1 minus cos x over sin x plus cos x 1 minus sin x over cos x. So this would finally look like sin x divided by sin x minus cos x. We have our division since it is divided over here, and then this would be multiplied over there. So this would be sin x multiplied over here and plus cos x minus sin x, and then this cos is divided, so this would be multiplied over here. So we'll get our final answer as sin square x over sin x minus cos x plus cos squared x over cos x minus sin x. Now we need to multiply this by negative 1 to get the LCM. So this would be sin x squared x negative cos squared x over sin x minus cos x. So we'll be getting our answer as, we'll be using a squared minus b squared over here. So this would be sin x plus cos x, sin x minus cos x. This will be cancelled out by the denominator. We will get our final answer as sin x plus cos x, which we had to prove. Now moving on to next question, that is B. Solve the equation 9 cot x plus 3 cosec x equals to 10x. So let's just solve this a little bit. So this would be 9 cos x sin x. Cosec x is basically sin x. So this would be 3 over sin x is equals to sin x over cos x. Since we don't need to take the LCM, since both the denominator are same, so this would be 9 cos x plus 3, but this would be multiplied by cos x, and then this sine would be multiplied over there, so this would be sine squared x, and we can use the identity sine squared x equals to 1 minus cos squared x over here to make the equation in cos terms. So this would be 9 cos squared x plus 3 cos x and 1 minus cos squared x. We bring all these things over here, so this would be 10 cos squared x plus 3 cos x minus 1. We can solve this equation by getting the roots as 5 and 2. This would be 10 cos squared x plus 5 cos x negative 2 cos x negative 1 equals to 0. So this would be 5 cos x, this would be 2 cos x plus 1, and this would be negative 1, 2 cos x plus 1 equals to 0. So we'll have a final answer as 5 cos x minus 1 and 2 cos x plus 1. So our cos x would be 1 over 5 and cos x as negative 1 over 2. What was our range? Our range was 0 till 360. We'll be including all the 4 quadrants. All 4 quadrants included. So if cos is negative, when cos is negative in second and third quadrant, and cos is positive in first and fourth quadrant. Let's just calculate our alphas of both. We'll get our this alpha is 60, and we'll be getting our this alpha is 78.46, I guess. So this would be looking something like, our answers would look something like this: 78.46. Second quadrant would be 180 plus 60, that would be 180 minus 60, that would be 120. Third quadrant would be 180 plus 60, that would be 180. And our fourth quadrant would be 360 minus 78.46, and our answer would look like 281.54. So this is our final answers. Now, thank you from my side. Do like, share and subscribe this channel. Thank you.